Hi, welcome to our series on organic mechanisms. Today we're looking at the haloform reaction. We start off with a methyl ketone with 3 alpha hydrogens. You have a delta positive on the carbon and there's a delta minus on the oxygen. And the electronegativity of the oxygen pulls the electrons towards it, which makes these alpha hydrogens acidic, which means they're susceptible to nucleophilic attack by the OH minus group. Here we have a lone pair on the carbon, which is not very stable, and you have an H2O formed. Here we're going to see a resonance form where the lone pair on the carbon forms a double bond between the 2 carbons. This is a highly resonance stable enolate ion, which is what drives the reaction forward. Now I'm just going to redraw the enolate ion. Now, the shared pair of electron in the carbon-carbon double bond, that electron is going to go and polarize the molecule on the right, and it's going to do an electron addition reaction. We're using XX, but it's just any halogen. So the product's shown. Now a similar thing's going to happen again where we have the lone pair on the oxygen attack another alpha hydrogen, but this alpha hydrogen's even more acidic than the one prior because of the electron withdrawing group due to the bromine electron withdrawing group. So again, we're going to get a H2O evolved and then a lone pair, which is unstable on the carbon. And again, we're going to see resonance stabilization, which drives the reaction forward. We're going to get another double bond between the carbons. So here we see another BR-BR molecule. And again, that C-double-O reforms. And then a shared pair of electrons from the carbon-carbon double bond that donates to the delta positive BR. And so we're going to get a di-substituted carbon. And now, for the sake of time, because this happens for a third time, we're just going to show the reagents. And we're going to end up with a tri-substituted methyl group. So I'm just going to redraw the N molecule. And we're going to draw in the partial charges because we're about to see a nucleophilic addition-elimination reaction occur. So that lone pair attacks the delta positive carbon. And the electron in the C double bond O moves the oxygen as well. And then we're going to see that double bond reform, which is going to kick off that CBr3 group. So we're going to end up with the carboxylic acid. And then also the CBr3. then the lone pair on the carbon is going to attack the acidic hydrogen on the carboxylic acid. So we're going to end up with a carboxylate ion and then some CHBr3. And then just showing this resonance stabilization of the carboxylic acid. So to summarize, we can have our overall reaction. We're going to start off with that methyl ketone. And then if you were counting 3 molecules of halogen and 4 hydroxides, which is going to form a carboxylate. So we can get our haloform, which in our case was bromoform. And you get 3 bromide anions. And then the 3 evolved waters. So that's our overall reaction. The haloforms can be used as refrigerants or used as intermediates in industrial syntheses. We hope you enjoyed this video and thanks so much for watching.